Hello, my name is Roberto Cavaliere. I came from Italy and I'm a certified mathematical trainer, and I work for the Italian reseller of Wolfram research, and it's Adalta, and I do technical support, training and consulting in the development. And today in this wonderful conference I have had the opportunity to present a work about how to construct interfaces with the Mathematica front end. Thanks to be here. So my presentation is about the use of Mathematica interfaces. So how to use and basic principles in order to construct interfaces, because it's a quite new feature. So we still need to focus on some topics. So that's the long version of the title, and the short version is just a guide if you want. So just a little check on the table contents. What I want to show is a first part with the key principles, and it's something common to all Mathematica aspects, and I would like to in particular focus on the what's dynamic. It's the main feature, the main command useful for the user interface creation, and so static versus dynamic. And everything is an expression that it's a common and quite known principle of Mathematica. It's still valid even in the cases of interface building and then automation. So these are general principles. Then I would like to go through some examples of basic components and behavior. So which are the basic elements we have and how we can combine each other in order to create even complex interfaces to our software. So the library of the built-in widgets and the kind of action, just to have a simplification of what we can do with such widgets in terms of actions. And then by the end, the composition and operation. So a conceptual framework about how we may intend from the theory point of view, or from a conceptual point of view, how is composed an interface. So with the visualization area and the control area, and we will see how we can customize both of them. And finally, an example of a special place where to put, so in the sense of a visualization area or control area, where we can put our controls and our Dochead cells. And finally, some example, if we have time, with practical use of interfaces in my experience, because I am a Mathematica trainer and developer. So I have done many of these experiments, and I'll show some of that. Here are some just introduction about the capability of Mathematica about interfaces. But let me start with the first principle, that's static versus dynamic. What's at the very basic level, the fundamental bricks of the interfaces, and it's the dynamic wrapper. So probably many of you have already seen manipulate or similar commands, but these are more like a macro that are able to arrange things, and I will show you some of them. But behind the manipulate, there is dynamic. So the most elementary function able to move things into the interface. So what's the concept? Here I have two lines with the same computation. It's a solve of an equation, a simple equation with the parametric parameters instead of coefficients. So I have the static version in the first line and the dynamic version in the second one. What it means that now with the modern version of Mathematica, we have two engines. We were used to have the kernel as the engine for the calculations, but now we have also the front end, that is the engine for everything we see in a notebook. So in this moment, the front end is listening to this dynamic object, and if the kernel will change in any way one of the elements that are appearing inside these dynamic elements, the front end will automatically upgrade, re-evaluate the full content of the cell, and then will refresh the video. So if I do something like that, I put A0, B1, C -2, I automatically get the new version of the same solution I already calculated, where the static version is still there because it's no longer depending from the kernel and what happens to the parameters. So this is the very basic element of interfaces construction, the dynamic objects into the front end. Of course, anytime I change the value, for instance, if I clear the values, I get back to the original solution. So dynamic, it's important because can be used in any pieces of code in Mathematica. So we will see many, many examples of how we can spread all around our code any dynamic pieces, dynamic of a small pieces or even a big piece of code. This is a dynamic object inside the graphic. So you can see this is internally to graphics, and I can check yes or not if I want a property like the axis of the graphic. Or here, I can have a mouse over feature. So when I move the graphic, I have the dynamic wrapping a disk with an if condition. So if the mouse is inside the area, it will be red. Outside the area will be blue. So these are examples of basic concepts of dynamic. The second important principle you should have in mind when you design your interfaces, or if you think to create interfaces, is the well-known slogan, everything is an expression. Because mathematics is a symbolic calculator, a symbolic programming language, so this is common in any aspect of Mathematica, so still in the interfaces it's valid. What it means, what makes the difference, because Mathematica is symbolic. With any other kind of language dealing with the contents, arrangement, and interfaces, you are able to do something like that. A tab view, that it's something to show contents according to different folders or pages, whatever you want to call it, when you click on the tabs. With Mathematica, because each of these elements are symbolic expressions, you can put whatever you want in each pieces of the tab. So for instance, this is the label 1, this is the label 2 and 3, and you can put whatever you want in a label, not just a string or an easy text. Here, for instance, I take some country data from the databases from sources of Mathematica, and I put a flag of the country and the shape of the country in the tab. So in other languages, it's not possible because there you typically have a string character, so you can put whatever you want in terms of text. In Mathematica, you can put any object, a graphics, for instance, but also something, you can do something like that. For instance, you can put a tab inside the graphic, even because it's a symbolic expression that you can put into the symbolic expression of the graphics. But what you can do, you can also change such elements. So not just static graphics or static expression, but even there you can put dynamic element inside any pieces of another dynamic element. So this is the very powerful aspect of interfaces in Mathematica, not easy to achieve with different languages. And because everything can be inside everything and you can move wherever you want, here is another example where I use a controller to move the tabs inside the graphics and also a slider to increase the number of tabs inside. And of course, even the contents of the tabs are changing according to the slider. So you can really do whatever you want because of the principle, everything is an expression. So the only limit to what I typically say here, it's your fantasy. Whatever you have in mind, you can realize combining such objects. Well, the other important key principle is the automation. It's another of the typical and well-known feature of Mathematica, and it's the many things the system is able to do without to ask the user to have a deep knowledge in each aspect of Mathematica programming. So even for interfaces, you have such a facility because, as you can see from this example, you don't need to know how to call a specific kind of control because the automatic behavior of manipulate is able to understand what you need. So in this example, I just have a plot that I want to realize in a dynamic way, so I put some parameters into the function. It's a plot of a signal where I want to change the amplitude, the frequency, and the signal nature itself. So I put amplitude, function, frequency, etc. This is the dynamic object. Which are the parameters? I just write the ranges where my parameters have to change and nothing else. So I will write for the amplitude and the frequency the range from 1 to 5. So it means, in theory, I would like to have infinity real values from 1 to 5. So the best control is a slider, and it's automatically selected by the system. When you have a discrete function like this one that takes only 5 values, it doesn't make sense to have a slider that in our mind it's something like a continuous values. So you have only 5, and automatically the system will decide to have buttons instead of a slider. And finally, if you put something that has to do with the colors, and you just say, okay, start with the green color, and by the end you will have at maximum the red color. That's all you need to say to manipulate. It understands you need a control slider. So here you can select the color, and all these elements are different, and they are suitable for what you want to do with such a control, and you don't need to have a deep knowledge, and the system, thanks to the automation principle, will be able to decide for you. Of course, sometimes you may decide, and I will show you in the next slide, that the automation selection is not suitable for your case. So you can take the control of everything and construct every control by yourself. Okay, that's just an example of if you increase the number of elements, for instance, automatically it's too much here to have a button bar, so the system will decide to have a pop-up menu. So it's better instead of have a long sequence of buttons. So just to show that when you change things, automatically the system will decide another thing. Well, these are the first. In the first 3 slides, I show you the principles. Now, just some technical aspects of basic elements or built-in function you have into Mathematica. So I took some examples from this list of widgets for the interfaces from a Wikipedia page, and then I tried to replicate almost anyone in Mathematica. So now I'll just show you the final result without to comment anyone, but just to say that we have almost all the widgets we need in any typical interface. So Mathematica is complete from this point of view. You have a button that can do some action, a checkbox, a radio button, and so on. So here is just to make some examples. I don't want to spend a lot of time. There are, of course, still because everything is an expression, you can add everything into such a built-in widgets. For instance, here I use some nice icons to create a toggle bar. So here you have the possibility to select multiple choices. So when you click, the variable will keep all the values you keep. So here are alternative values for the same values. So this is a setter bar, and this is a toggle bar. But just to show you that you can add your icons, so to create interfaces that have nothing to do with the original code, and the end user can work in a very comfortably environment. That's a grid view and an hyperlink, and just to show you that any kind of behavior can be used into Mathematica as a built-in widget. But now, and here is a link to the documentation center where you will find all the elements well documented if you need to go deeper. Now, we have seen that we have many built-in elements, buttons, radio buttons, toggle bar, etc. So in my experience, I need to simplify the things. So what I have done in the past is try to understand, I have, I don't know, 20, 30 different widgets. Can I simplify in terms of what they do, what kind of actions they do? And I finally get 4 different categories of widgets. So normally what we need to do with an element that could be a button, a tab, or something else, is to execute a generic code. So the first action, or kind of action, is the execution of a generic Mathematica code. So you can run an integrate, you can run a limit, or even a complex algorithm by means of an element from the interface. Then another typical use is to, if you have a dynamic object somewhere in the notebook, and the object depends on some variables, you need to change the values of the variables. So another category of widgets is that is able to change the value of a variable. And then the other to arrange the results, so the data visualization. And finally, the input of user data, because many times you don't know a priori what's the value. You may know the range, but the user may specify an exact value, so you have to provide the possibility to insert the data directly from the keyboard. So now, just a little focus on each piece of this kind of action. These are just any kind of action you can put inside an element of the interface. For instance, this opens a particular folder in my computer, or these other buttons create a document and put inside the document the list of files that he reads from another folder. So just to make some brief, short and rapid examples of kind of code you can create under your button. This create another document and put a cell inside, and this make a calculations and print the results. And here, once again, I create a toolbar with some nice icons, and then I do two operations for each button. First, I have a graphic. First thing, I export the graphic in a particular format according to the label in the image, and then I open the system default application for those images. So if I click on GIF, I automatically am exporting the GIF image, and automatically Mathematica opens my default application for the GIF visualization. So you can control whatever you want from inside Mathematica thanks to the interface. And your user don't need to know about that commands, because just use buttons or easy-to-use interfaces. This is a similar in the different way, but does the same things. So export the object and then open the standard application to see the object exported. Well, the other category of actions is the variable assignment update. And we have seen some example already, but just some others. So here you have a variable inside the graphic, and you need some control to change the value. So anyway, you are running a code, but it's a particular kind of code that it's just updating the value of a variable. Here, change the background of the notebook. So there is no limit of what you can do with variables and buttons that change the variables. Here it's still, once again, something related to a graphics, and here a combination of colors. So here you are just using interfaces to update a value of a dynamic object. Then the other one is still quite easy. I'm not sure how many, 8 minutes, so, okay. That's some very easy. It's the data visualization. We already have seen an example of a tab view or something else. And here I have, once again, data taken from the country data, and then I change different way of arrange results. So this is a tab view, and this is a flip view. So you can click and change, or you have a column with buttons. So there are many different types of widgets able to arrange contents in the way you want. Finally, that's very easy because for the data input from the user, you have just a command that it's the input field. So here you can have any kind of a string in that case, but even expression or number, whatever you want to have as an input from the user. Well, that's the behavior. Finally, the composition and operation. So now we have seen the basic elements and how we can combine them in order to create interfaces, but how interfaces should look like. In my idea, still, once again, to simplify the conceptual idea of an interface, we can divide an interface in two parts. There should be something to control and something to visualize the contents that are controlled by the controls. So I defined the control area and the visualization area. This is an example of a control and visualization area from a manipulate. This is another example from the use of a palette. So you have the visualization that could be the whole notebook or a part of a notebook, and then a palette that represents the control area. Anyway, there is such a kind of conceptual idea. So what we can do in each of such area, can we customize both? Of course, because mathematics allow every kind of customization. So just an example of the visualization area that can be anything. This is a table changing with some value of the calculation we do, and this is another table arranged by elements in the country data. And so the visualization area can be anything, not just a graphic, because usually many people think that manipulate are for graphics, not only for graphics, but you can do whatever you want into the visualization area. Here is just an equation solver, still for an equation of second order, and you may change the coefficients and see if the solution exists or not. So there are any kind of object. Here I use a panel, a grid, so you can use such a widget to rearrange contents. What about the control area? The control area, it's the place where automatically or custom, as we can see now, we can put the controls to change the objects in the visualization area. So just an example of when it could be useful for us to understand how to customize the control area. Because I have seen before in the automation principle that many times manipulate arrange everything in the right way and you accept without to change anything. But sometimes you may need to change something. So it is possible. And that's an example. If you want to put 3 slides of such an easy control in vertical, and you discover that there is a control type vertical slider, but the automatic arrangement of the slider is not so nice because it creates a long version of the graphic. So I would like to have a different one, but there is no way to have in automatic. So what I can do, I take the control of the control area and I create my own grid of controls, arranging them as I want. So this is another level of customization. So I take a grid, I put some names in the top of the column, and then I put a singular vertical slider in a easy way. Yeah, okay. So there are some times when the control area meets the visualization area, in the sense that many times we need to have a control directly into the visualization area. And it's typical when you have graphics. So we can do also that thing. So you can have just one moment where controls are inside the dynamic area. And this is an example. If you want to know the color where the click is, you just click on the graphics and automatically, so you have the control inside the graphics. Not necessarily you need to separate the 2 areas we have seen. Here is another example with a point on a circle, and then I manipulate with an interpolating polynomial where I can change the value of each point directly from the graphics with the locator. So in that case, there is no an evident difference between the visualization area and the control area. I have still 3 minutes, okay. Just a couple of minutes of delay, okay? So I'm quite to the end. Yeah, and now we are to another special place where to put, still speaking about visualization and control area, where we can put the controls. There is a particular nice place where you can put your control, that it's on the top of the notebooks, the so-called the Dochead Cell. So there you can put your control. So you have always in front of you without to change a swap from one file to another. So that's an example of a Dochead Cell, that it's the slideshow Dochead Cell. But as you can see, I customized the Dochead Cell in my computer, in my example, and I have here, for instance, the minutes remaining for my presentation till the end, as foreseen from the scheduling. So that's a custom Dochead Cell, but I show you some example. Here, so the easiest way is to create a document and say the option Dochead Cell is something. I have no time, of course, to explain the code. I'm just giving you an idea, a panorama of what can be possible. Then you can have the document from the conference and you can check the software, the code. So that's a button. It's sometimes very useful because remember you that you have to save your document and you have in front of your the Dochead Cell. Or you can create something like that. It's a search area for your document. So if you have a long, I don't know, if you write a book or paper and sometimes you need to change a word, you don't like a word, so you have a search on the top of the document and you can search all the words, etc. So we have any kind of control into the Dochead Cell. That's another nice coming from my experience of technical support at Wolfram, and a user to ask me for such an example in the past. They were used to have many palettes open at the same time while writing something. So, and the problem was that in any moment you want to close all the palettes, but then you want to reopen in the same way you arranged on the screen because you are working. So if you close each one by each one, you spend a lot of time. So I have done such a button that just in one way, click on the button and every palette go away, and then you can recall instantly. So what you can do is to have all these elements in the same document and have the search and then the others. Yeah, 0 minutes, just a few minutes again, and then whatever you want in the Dochead Cell. Let me go to the end. So just a couple of examples of practical things. That's a calendar. For instance, if you work on something about data and you need to know in every year or month or day how is the situation into the calendar. Or, for instance, if you want to create a style sheet and you want to see how your fonts looks like and the type of colors, etc., you can create such template and then you can work on any elements, even change the palette of the colors, and then you apply to the system. So that's another example of interfaces. Sorry for my voice. Okay, I stop here. Okay. More or less, it's the last slide. So
all right,
thanks,
thank you.
everybody.